Good morning, everyone. My name is Wachirapong Jirakitpuwapat from the Faculty of Science, Energy and Environment, King Mongkut's University of Technology, North Bangkok, Rayong Campus, Thailand. Today, I would like to present our work entitled Machine Learning Assisted Optimization of Antioxidant Activity from Black Rice Bran Extracts using Face-Centered Composite Design. Thai indigenous glutinous rice with a black pericarp has a pleasant aroma and soft, chewy texture when cooked. Known as Luan Foga, forget the husband, its delicious taste may even make people forget the soulmate sitting beside them. It is also rich in antioxidants. Antioxidant activity is closely associated with the presence of phenolic compounds, including flavonoids and anthocyanins. Higher levels of these bioactive compounds generally contribute to stronger antioxidant capacity. Ultrasonic assisted extraction, or UAE, is considered a green extraction technology. Ultrasound waves enhance mass transfer and facilitate the release of bioactive compounds from plant matrices, resulting in improved extraction efficiency and reduced processing time. In this study, extraction time, extraction temperature, and solid-to-solvent ratio were selected as independent variables. Antioxidant activity was used as the response variable. Machine learning techniques were then applied to model and optimize the extraction process. The methodology consisted of 3 phases. Phase 1 involved experimental design and extraction. Phase 2 focused on predictive modeling using machine learning. Phase 3 involved process optimization. Experimental data were first collected using face-centered composite design, then several predictive. Finally, the best model was combined with particle swarm optimization to determine the optimum extraction conditions. The extraction experiments were designed using face-centered composite design. 3 factors were investigated. Extraction time ranged from 25 to 35 minutes. Extraction temperature ranged from 30 to 50 degrees Celsius. The solid-to-solvent ratio ranged from 1 to 15 to 1. A total of 20 experimental runs were conducted, consisting of 8 cube points, 6 face-centered points, and 6 center points. The antioxidant activity was selected as the response variable. After obtaining the experimental data transformation was performed. Several machine learning algorithms were trained, including artificial neural network, Gaussian regressor, linear regression, ridge regression, Randstad regressor, elastic net, and lasso regression. Feature importance analysis and backward elimination were applied to remove less influential variables and improve model performance. Representative models were selected and compared to identify the most accurate predictive model. Model performance was evaluated using 3 statistical indicators. These indicators included the coefficient of determination, adjusted R-squared, and root mean square error, where R-squared measures the goodness of fate. Adjusted R-squared accounts for the number of variables, and RMSE represents prediction error. These metrics were used to compare the predictive capability of different models. Residual analysis was conducted to validate the developed models. The mean error and standard deviation of errors were examined. Normality of residuals was tested using the Kolmogorov-Smirnov test. Independence of residuals was evaluated using the Rojong box test. This analysis helped ensure that the prediction errors satisfied the assumptions required for reliable modeling. This slide shows the results obtained from the artificial neural network model. Different combinations of input features were investigated using backward elimination. The model maintained high prediction accuracy even after reducing the number of variables. The results indicate that N can effectively capture the nonlinear relationships between extraction variables and antioxidant activity. This figure illustrates the prediction performance of the N model. The predicted values show good agreement with the experimental values. Most data points are located close to the ideal line, indicating strong predictive capability. This result demonstrates that the N model provides accurate. This slide presents important feature vectors and the residual analysis of the N model. The residuals are randomly distributed around zero without obvious patterns. This indicates that the model errors are unbiased. The residual analysis further confirms the adequacy and robustness of the developed N model. This table compares the performance of all machine learning models. Among the 7 models investigated, the artificial neural network achieved the best performance. The N model produced an n-squared value of 0.966 and an adjusted R-squared value of 0.941, with the lowest R. In addition, the residuals satisfied both normality and independence assumptions. Therefore, N was selected as the best predictive model for optimization. After selecting the N model, particle swarm optimization was employed to determine the optimal extraction conditions. The objective was to maximize antioxidant activity while maintaining the variables within the experimental boundaries. The N model served as the objective function, and so searched for the optimal combination of extraction parameters. The optimization results predicted a maximum antioxidant activity of approximately 68.19. The optimal conditions corresponded to an extraction time of about 37.65 minutes, an extraction temperature of approximately 17.29 degrees Celsius, and a solid-to-solvent ratio of around 30.58. In conclusion, this study demonstrated the successful integration of experimental design, machine learning, and optimization techniques for maximizing antioxidant activity from black rice bran extracts. Among the investigated models, artificial neural network exhibited the highest. By combining N with particle swarm optimization, the optimal extraction conditions were successfully identified. This approach provides a promising strategy for the development of efficient and sustainable extraction processes in functional food applications. Thank you very much for your attention.